Welcome to this episode of Cadenza Design Guides. One of the unique features of an embedded system application is its use of sensors, buttons, and more. Today, we'll learn how to access your hardware from a TouchGFX application. Let's begin with a simple goal, to display how many times a button's been pressed on the screen. I'll be using this STM32F769i discovery board for this tutorial, but you can use any development board with a button, even your own custom hardware. Our screen consists of a text area. We'll add a wildcard and then include the entire ASCII range in our wildcard ranges for this font. Wildcards allow you to programmatically change text in an application. Check out our other design guide on this topic for more details. I also have a second screen, which we'll use later, and buttons to switch between the two. Finally, we set up an interaction so that TouchGFX generates code to switch the screens. Getting the GPIO status from a button is pretty easy with the STM32Cube HAL. Here's a simple main function that pulls the GPIO and turns on the LED when the button is pressed. Where should we put this GPIO pin check in our TouchGFX code? Here's a map of the classes in our application. Don't worry if you're unfamiliar with each of these classes, we'll examine them in this video. We want to make a widget do something when the button is pressed, so maybe we should put the code in the class that contains the widgets, the view class. If we look at the header for the view class, we see that it inherits from a view base class. If you browse through it, you can see it contains all the widgets that we added to the screen. We can't write our own code here because TouchGFX will overwrite it the next time we generate our project. Let's return to the view class and add our code to check for the button press. First, we'll create a member variable for the button count as well as the last state of the GPIO pin. We'll initialize these values in the constructor, and we'll initialize the wildcard in our setup screen method. We can make a view do something at the beginning of each frame by adding the handle tick event method. Here, we'll use the STM32 HAL code to get the current state of the pin and compare it to our last saved pin state. If the state is different than last time it was checked and it's pressed, we'll increment the count. If we test this on our board, we can see that it seems to work. But there's a few problems with this approach. Here's the first problem. When I switch between screens, the count is reset. This is because when you leave a screen, all its data is destroyed. When it's entered again, the screen is created from scratch. The second problem is that we might need the button code again on another screen, so we'd have to duplicate all the code we just wrote. Later, if we want to update, say, the GPIO pin, we'd have to fix our code in multiple spots. The third problem is that this view class might contain some fancy complex animations or other visual effects later. If we mix all that up with hardware code, it will become unfocused and difficult to maintain. So, where's the best place to put this code? Let's have a look at the map again. Each screen has a view and a presenter, which are created when the screen is entered and destroyed again when it's exited. This is why we can't store our count here. The model, on the other hand, always sticks around. We can store the count here so that it would exist for the life of the application. Then, each time the screen is loaded, we'll set the value of the text to the value stored in the model. Let's move our GPIO code to the model. Here, I'm just repeating what I did in the view class by starting with a member variable, initializing it in the constructor, and adding our logic to check if the pin has changed and increasing the count if it's pressed. In our view, we'll create a dedicated function for changing the value of the wildcard. Now, how do we load the model value into the view when it's created? If we look at the map again, we can see that the presenter is our link between the model's data and the view's functions. The presenter's activate method will automatically be called when the screen is entered. Here, we'll access the data of the model and use it as a parameter to the method of our view that takes care of updating the text. When we run our application, we notice that although our count doesn't increase while we're on the screen, if we move between screens, we can see that each time our count screen is entered, the value is correctly set. We could create an accessor method in the presenter and constantly pull the model's value from the handle tick event of the view, but there's a better way. Instead of polling, we'll have the model tell the presenter when the button's been pressed. That way, the presenter will know to read the new count value and update the view. We'll create an onButtonPressed method in our presenter. and then we'll call it from the model when the button is pressed. But how do we access our current presenter from the model? The model doesn't actually know which of the presenters is active at any given time. If we look in the model's header file, we can see that it has a pointer to a model listener instead. If we look at our presenter classes, we can see that they both inherit from this model listener class. The model listener class itself is just an interface, and in the background, TouchGFX will automatically reassign this model listener to the active presenter. Now, the model doesn't need to know which presenter is active. So long as the method is present in the model listener, it will be usable in all presenters. We can force all presenters to implement the onButtonPressed method by defining it as a pure virtual function. But not all screens will care about this button. Instead, we can implement an empty function. Now, when this method is called, the default behavior is to do nothing, except on presenters that override this method. Let's add the override keyword to our presenter method and reference our model listener function. Voila! The count now updates the screen each time the button is pressed, and the count stays correct even between screen changes. Let's step through the program to solidify our understanding of how this works on both our count screen and the other screen. If our count screen is active, the call from the model goes straight to the presenter, which accesses the count variable and updates the view. If we're on our other screen, the button press simply goes to the empty model listener implementation, and nothing happens. Let's review what we've learned about each class. The model always exists in the application, so it can be used for storing persistent state information. It's a great place to add the code to interface with your hardware. Regardless of the active screen, it can call a model listener method in the background as hardware events occur. On each presenter, you can decide whether or not to respond to the model listener calls. If a call is relevant to the screen in question, the presenter can be notified, fetch data from the model, and then call methods on the view with that data. The view is left in charge of handling the nitty-gritty calls to the individual widgets. Cadenza Design specializes in GUI development for embedded systems. We can help you bring your vision for your embedded user interface to life. Visit us at www.cadenza.design or email us hello@cadenza.design. We hope you found this video useful. See you in the next one.